Hi guys, welcome back to lesson number 3 of our series Fusion for Production, VFX Compositing inside of Fusion. My name is Helge Maus from pixeltrain. After our first 2 introductory lessons, we now want to dive deeper into Fusion VFX Compositing. And the first topic on my list is deep pixel nodes. First of all, we have to talk about the term deep pixel nodes, because inside of another compositing application, NUKEX, there is a deep compositing workflow. And people are asking a lot, is Fusion able to do deep compositing? The honest answer is no, it isn't. Deep compositing is a really special technique in which every pixel has multiple depth values and also contribution. And so it's great for volumetrics and it handles anti-aliasing much better, MotionBlur and things like that. But it's really its own toolset also inside of NUKEX, and Fusion has not a toolset like that. The deep pixel nodes inside of Fusion have 2 different approaches. One approach is a Z-based workflow. That means Z means the depth, which can come from your 3D application, for example, the depth path. If you know what a depth path is, you know that a depth path is dependent on the pixel resolution of your plate. And a depth path, like all other data passes, is never anti-aliased. That means the resolution of the plate is really crucial for the quality you later get from your Z-based workflow. The deep pixel is also a technique which is really similar to the channel system inside of NUKEX. So in NUKEX you can have thousands of channels. Inside of Fusion you don't have so many channels, but if you map your information correctly, you have a bunch of channels, and we normally say these are the auxiliary channels inside of Fusion, and you transport with every pixel then these deep informations through the node graph. And we have a whole bunch of nodes which I want to show you in this tutorial, which then use these information for their work. For example, for depth of field, for MotionBlur, for ambient occlusion, for retexturing, and many other things. Like I've said, I show you that here in this tutorial. You see, I've opened here Fusion Studio, and I have here now a 3D scene here. You don't have to build it now, but I decided that I don't want to show you now this with OpenEXR sequence from other DCC, for example, like Blender or Maya or so, because it's really important for you that you first understand what a deep pixel is and which information you can feed into the system and how they look, because there are no standards out there for a Z path, for example, or world position path and so on. And really often you have to convert stuff. And I don't want to show you in this tutorial how to convert something. I think this is really confusing. So I decided that I built a 3D scene inside here of Fusion. Yeah, you know, I've imported an FBX, I show you that. And then we render this 3D scene inside of Fusion so that we get the correct for the Fusion readable data. And then I can explain exactly how the data has to look. In the next tutorial, we then take, for example, a renderer sequence from Blender and we convert it correctly and then bring it into the flow. So I hope this is good for you. For everyone who's starting out now with Fusion and doesn't have the commercial version of Fusion Studio, I decided also that I go into Resolve. I use this chance directly to show you how you can bring a Fusion composition which was made in Fusion Studio directly into your Resolve environment. So let's get started. You find all these files on my Patreon if you want to use them, but you also can use your own stuff if you like. Okay, let's go over now to Resolve. Inside of Resolve, we start with our project, which we used last time. And you see, I start here on the media page because I want to show you how to import now the stuff from our data package. You see, here is my data deep pixel, and you see I have a whole bunch of folders. Last time we dragged now files into that here, created with the right mouse button bins and so on. I want to show you a faster way. So if you have here bins, for example, texture, and you have stuff inside, what you can do is you can directly take here this bin and drag it here into your bin list on the left side. And all the stuff which is inside the folder is then copied over. Same for HDRI here. Then we have here the Fusion comp, which we don't need inside of this system because we have to import it. But here EXR has a file inside of that. And here is a folder Blender files I imported here and I drag it here onto master. If you by accident drag a folder here into another one, the solution is drag it out here to the master and then you have it back here on the top level. So inside of the Blender files, you don't see the blend file here, also now here, but you see you can import into your project an FBX file. So that's it. Now we make our Fusion comp, and this is something we talked a lot about in the last lessons. So I go here now to the timeline, open my media pool, and I go here to master, make a right mouse button click, make a new timeline, and we name this timeline Deep Pixel. And I go to the project settings and change them, because if you go now here to the Fusion comp, you will see that I used here 25 frames per second. And I want to use the same frame rate also inside of my Resolve Fusion. So let's go over here. And you will see that if you untick now use project settings and you go here to format, you see that my project is set up to 30 frames per second as a standard. But for this timeline, because we want to use it only for Fusion, we go to 25 frames per second. Now we can create the whole thing. It's empty. And here we have now to place a placeholder for our Fusion comp. You find it under Effects, Toolbox, Effects, and here's the Fusion comp. Place it, and if you want, you can now go in here and tell the system how long it should be. So it's too long, but yeah, we can change that later. Now, our time indicator is over Fusion composition. That's great. So switch over to the Fusion page, and now we are back where we left last time. And we have an empty Fusion comp. The only thing we have is the media out, because you remember this is the connection to the timeline. So if you output something here, it comes over to the timeline. To now get the information from the Fusion Studio, there are two ways. First way is you go here to Fusion, select everything and copy it into your clipboard. Go over here and click somewhere where you want to place the nodes and paste. And now you see your node tree is here. Really clever, right? But there's a second way. The second way is if you are on the Fusion page and you have prepared everything, you can go here inside of Resolve to File, Import, and here you can import a Fusion comp. If you do that, you will see, here's the Fusion comp, which I've opened in the studio. You will see that this here is now a new comp. And our media out is now gone. So that means if you go back to the timeline, you don't see anything here. So keep that in mind. So you need a media out here if you want to output here to the timeline. Let's do that. And I use now here the shortcut Shift Spacebar to search for the nodes. But if you are not sure where to find the nodes, you also can use the right mouse button here. Add tool, go to the folders like Input Output, for example, for the media out. Or you can also open here the effects and open your tool set. Some people prefer that in the beginning, and we can drag a media out here, and that's it. And now this media out delivers the data. Okay, now let's talk about this 3D scene thingy here. I take this scene here and I load it with the keyboard shortcut 2 into the viewer number 2. You look through the camera. If you don't see here the look through the camera, you can make a right mouse button click here on this little axis system, and here you have perspective, top, front, left, right, and so on. And here you see the names of your camera, and the camera is named camera, so I switched it here on. If you drag the same thing also here to number 1, you see here we look into the perspective and we can navigate here with the middle mouse button. You pan around with middle mouse button, Alt key. You toggle around the selection. If you want to reselect something, little tip, select for example here the torus, press Command F like frame. Now you frame on it, and now also here the tumbling around goes now around this torus here. So this helps. And you see zoom in and out. You can use the mouse wheel, or really crazy thing, you can hold down your middle mouse button, also the left mouse button. Yes, both mouse buttons or mouse wheel and the left, and you can drag to the left and the right. This also works. Okay, now this is the 3D scene, but you will see that you can't connect the output of the 3D scene here with the media out. you see it doesn't work. Reason for this is 3D, and 3D has to be rendered with the camera and so on. That's the reason why the media out doesn't accept it. You don't have a renderer. We have here a 3D renderer, so take one, place it here, and now we pipe the output of this scene, which is like a collection of all the stuff which is connected to it, to the renderer. And if we now drag the renderer, for example, here into that, you see this here is the view through the camera. You see here the guides. You can activate them with Command G. Yeah, so you get your guides, or you can make a right mouse button click guides and activate them here, show the guides, and here you can tell which guides you want to see. And this here is now the rendering of the whole thing, and it looks a little bit different. Reason for this is here in this scene, in this 3D scene, we have different options here, and if you click this here, you see we have a solid view, which looks like this. This is the same here. But we also can activate lights, and if you don't have a light source, you get a standard light, but I have a light source, which is a directional light here, so you get lights. And you also can activate here the calculation of lights and shadows. So this is the 3D scene, but the renderer doesn't seem to work like that. You see, we still see this solid view, and we don't have these ticks because this is really the output. To do that now, you select the renderer here, and I make this panel bigger so that you see it better. And inside of the render panel, we can now first switch the renderer from the software renderer to the OpenGL renderer. That's the first thing. And now you see you have much more options because it's much more powerful. Here under lighting, you can now say that you want to have lighting and also you want to have shadows. And now you see it looks now the same. You have many more options here, but that's not the topic of today. The only thing which is maybe important, if you have more than one camera, you can select here the camera, but default means the first camera it finds. Under image, you find now the size of the output plate, which is in the moment correct. It's full HD. That's exactly what we want. And here's the depth. We can tell now which depth we want to have. For example, you say we want to have float 32-bit. So we now tell the system we want to have that. And if we zoom out here now, you see this is a full HD plate with float 32-bit. And this is something we now can connect to the media out. And if we go now here, look at that. We have now this scene. I press Shift Z here to stretch my timeline. And you see in the file here, we have then this guy flying around. It's important, but we then can cut here the whole thing at this point and say we don't need any more because our fusion comp is shorter than that. Okay, let's go back. Now the preparation is done for us. Great. The next step we now have to do is we want now to talk about these deep pixels and channels inside of Fusion. So what are channels? I want to show you something. I take a loader. I take here this loader connection, or you can, if you haven't added the icon, you can type in loader here. And we load now, for example, here this EXR file, which we have imported into our system. I load it directly now with the loader because I want to show you something. I drag it here. And you remember that we looked into this file before, in the lesson before. And you remember that if we have a loader, we have here under format a channel mapping. If you go here to format, you see it's OpenEXR file, and then we have a channel list here. And we talked about these mappings here, and these channels here are typical channels or the predefined channels which Fusion wants to have for the deep pixel workflow. And your job as an artist is now to map them correctly. You can do that really easily by going in. You see, we see at the moment the ambient occlusion. So the name is view layer, ambient occlusion, and this is red. It's piped into the red channel, which we normally see. What you see here is RGB and alpha. And now you can go in here and you can map now the channels which are inside of the EXR. And I know it takes a while, but you get used to that. So we go here, take the combined RGB. And then we also want to have the alpha, so we can take the alpha combined, and you see it looks really dark. Why? Because we don't have the correct LUT here. We talked about that before. So let's go here and say this is an sRGB, and now you see this is the result. So this is the first contact for you with the channels. And now you see we can map now all of these here. This is something we will do in the next lesson a lot. If you take now directly from the media pool the EXR, you remember that you get a media in here. And the media in works nearly the same. If you drag it in, this file is special because we don't have RGBA data here correctly in the first place. You see you get it red, but inside of the media in you can go here to the layer and say show me the layer combined, and then you will see that you get the correct image, because this layer drop down here helps you to map much faster these here. But the rest you have to map for yourself. So you see, these are the channels which you can deliver in from an external file. After we've now recapped this here, we go back now to our render here. And the question is, if you render out a 3D scene now from Fusion itself, you can have all kinds of channels directly from this render node. And this is really cool because that's the way you learn how these channels look. Let's search where it is. If you select the renderer here, you have 3 tabs, and if you go here to controls, you will see that we have here now an output channels list. Remember that we switch it to OpenGL renderer. If you go to software renderer, it looks a little bit different. So take the right one here. And you see at the moment that our renderer only outputs RGBA, so standard. Let's take a look into the user interface. If you place now your mouse over your image, and I see it's too bright. Why? Because this here is not a linear image, so deactivate the LUT here. You will see that here in the status bar, you see the color RGB and the alpha at the moment. So these are the information which are underneath the pixel where our mouse here is placed. You also see, if you go here into that here, that we have here channel list. You see the combined RGBA result, but you also can see the separate channels and the alpha. And this is something you can switch here around, or if you click here, it always toggles between RGB and the alpha channel, but nothing more here. In the moment you say now that you want to output more, I go here and click the Z. You will see that if you now hover with your mouse over the pixels, you will see that in the status bar you have an additional Z information. Now this pixel is deep. You have more information behind the pixel. Z means the depth, how far this hit point from the camera is in the distance. And you see it's really special inside of Fusion. It's negative because, yeah, you come from the camera and you go into the negative Z direction. So keep that in mind if you come from a 3D application, that Fusion thinks Z is negative if you have a depth. You also see it here now in the list. So if you open that up, you see here Z, and if you switch it on, in most cases it's bright white. The reason for this is our viewer is not able to show us negative values. You remember the point was -18, for example. To bring now the whole histogram together so that the viewer is able to show it, you can go here to the 3 dots and switch on here the normalized color range option, or you can also do it somewhere here under right mouse button click options and normalize color range here. And then Fusion tries now to bring the whole histogram together, and now you see how these pixels go into the depth and go into negative values. So you see this is close to the camera and this goes more far away. So this is the depth channel which we generate. And you can analyze it by hovering here, or you can see it here inside of the viewer. Now let's talk about the first deep nodes. Let's go here to the effects, and if you go here into the effects now, you see that we have now here a subfolder with the name deep pixels, and these are the most common nodes here. But keep in mind that there are also some other nodes which use these deep pixel data which are not here in the list. We talk about them in the end of this tutorial. The first node we want to talk about is the Ambient Occlusion node. So let's drag this ambient occlusion node in here into the stream. We directly want to see it, and you see the ambient occlusion node is not happy. And this is really important that you see it. So if a node gets red, it means it's not happy, something is missing. For every of these deep pixel nodes, you need some channels or deep pixel information so that they can work. For the ambient occlusion, for example, we need normals and the set depth. And we don't have a normal pass at the moment. So that's the reason why it's not happy. If you go now back to the renderer, you can say, hey, I want to generate normals. And if you do that, and if you now bring this guy here back into the viewer, let's go here and bring it to the viewer number 2. One thing I've forgotten is it needs these two, normals and Z. And what it also needs is it needs a camera. So if you hover here over this little input, you see it needs a camera. You can go here to the camera of your scene. That's the normal way, because it asks you which camera is used to produce this image. So if you import an EXR, for example, from a 3D application, you also have to deliver the camera data. So you can directly hook it up here, or you can also hook it up to the scene, and then the node searches for the first camera it finds. So let's hook it up here directly to the camera, and now you see it works. So this is the classic look of the ambient occlusion node. And what ambient occlusion is, it's the simulation of bouncing light. Bouncing light simulation, global illumination is a really calculating intensive process, and ambient occlusion was a fast way of calculating that here, where it finds connections between surfaces and then we get a gradient in both directions and so on. And this is this effect here. So it's screen space ambient occlusion. You see here there are different kernel types, how it's calculated, and the first thing we normally have to do is we have to check the radius here, because this is dependent on the scene size. So you will see how big the scene is and how far this gradient is produced. And this is something you normally have to check so that it fits to your scene. Then the quality of the whole thing, normally ambient occlusion is noisy, is something you do with a number of samples. Be careful with that. It takes longer if you increase it too much. And what you also can do is then we can tweak now these colors which you see here and so on. But this is something you can read later in the documentation. But the takeaway from this is now, through these deep pixel information, the ambient occlusion is able to build these data. And remember, this here is a 2D image which comes in, and we only deliver the camera and these two data passes, Z and normals. And what you now can also do is we can use it. For example, if you now go here and say we want to use it somewhere here, let's take a merge node, and we take the original image, this is the original image, and you want now to have stronger shadow, for example. What you can do is you can take, let's get rid of that and hook it up here. You can now take, for example, the output of the ambient occlusion and merge it over the original image, which normally occludes the whole image. But if this here is, for example, a shadow, you normally apply shadows with a multiply effect. So you go to the apply mode of your merge and say, I want to multiply it. And if I switch it on and off here, you now see we get an additional shadow. And then with the help of the blend, we can tell now how much we want to have. So this is one use of this ambient occlusion node. The next thing we really often want to do, let's get rid of that, is we want to have depth of field. And depth of field is something we can really accurately calculate inside of the rendering process, but it takes a long time. Really often we want to do it in post. And for this, we have under the deep pixel here the depth blur. Let's place it in here. And you see this time this node is happy, because the only thing which depth blur really needs is a set depth pass. And we have it. You remember, we activated it here. If you don't use it and you drag it in, you get nothing useful at this point. So let's now look into the depth blur here. Where is the right viewer? Let's take this one here. and we deactivate viewer number 1 here so that it doesn't take resources. So inside of the depth blur, we now can tell here which is the channel which we want to use. In our case, Z is standard, and that's good, because if we now go here and hover over this, you see here the values, the Z values. And if I now place my cursor here, for example, over this cube here, you see this is in a distance of -14, for example. What we now can do is we can first overdo it. I bring the depth blur in, I go here and blur the whole image a lot. If it doesn't work at all, you see here's a little bit of blur, so it's not too strong. You can go into the Z scale and bring it first to 1. I think this will really blur it a lot. This is like a multiplier for the whole thing, so 200 is a big one. And what you now see is, okay, everything is blurred here with around 8 pixels now. So if you now want to place somewhere your focal plane, what you can do is you can work with a focal point here. You can type it, or you can click here sample, and this is interesting. You hold down your mouse after you clicked here sample and move now your mouse over the image. And now you see you get a little indicator, and you read out here now, for example, we wanted to have the cube here, that we are around -14. And now this here is in focus, so this is the focal point, and you now see that the rest here is blurred. And now you can bring down the blur size if you like again. You also have a depth of field, so a corridor which is in sharpness. We can do that here, but I think you see the concept here. One important thing here is that the depth blur doesn't look too good, so if you're really planning to use it a lot, I would recommend that you use an external plugin for that. So there's an OpenFX version of Frischluft Lens Care, for example. It's around $250, so it's not too cheap, but yeah, it looks much, much better. But if you don't have something external and you really want to use that, there are also some, I think, external tools which are free. But Frischluft is one of the standard things which people use. But this here is built in, and it works like that. So this here is using now the Z. There are many ways of manipulating the Z. You have seen here we can scale it here afterwards so that it's not so fast and so on. But I think in the next lesson, when we talk about VFX compositing with an external EXR, I show you some more ways how you can manipulate them. Let's get rid of our new friend, the depth blur, and take the next one, which is the fog. The fog also needs set depth, because we need to know how far something is in the scene. To now really see the fog, let's drag it in. You sample two things. We have a near plane and we have a far plane. So same thing, I click here on sample, hold down my mouse and go here into the front. I hold down now my mouse here on the far plane sample and I drag it here. And now suddenly you see now we have a fog between these 2 points, between -8 and -26. And now we can scale again the set, same thing like we saw in the depth blur. And here's the fog color. I want to have it grayish, for example. And you can change that here a little bit. And then we also can manipulate here a little bit the colors. We have an alpha and a fog opacity if we like. So this is using Z again. You see, it's a really cool thing. There's another fog. I think it's named the volume fog. Here it is. Okay, let's drag it out and take a look here. Let's take the plane here, drag it in. It's not happy again because we need, I think, a camera and a world position pass. Let's take a look here. This is the scene input, so I think this is for the camera. Here we go. And we need a world position pass. So world position pass is generated with world position. And if we do that now here, you see now the node is okay. And what you now see is a really interesting thing. You can now see here this little thingy going on. Let's first make pick and we move this picker here. And then we switch this here to sphere. And then I think I have to explain what a world position path is, right? So let's go back to the renderer. If we have a scene here, the renderer knows exactly how far a point here is from the camera, and it's normally stored in a Z path. But it also knows, when it's rendering, which position in the 3D scene it has. So if we look into the 3D world of the whole thing, you will see, let's go out of the camera, right-click, perspective, you see that every of these points here have a 3D coordinate here in this coordinate space. And what we can do is we can store this coordinate for every of these pixels as a deep pixel information. And this is done here in the renderer with world position. You can also see it here. If you then go into the renderer again, and here into that, you see here are the normals and here are the positions. You can see every channel here separately. So this is the X value. And remember, you really often don't see everything because we have negative and positive values. So if you really want to bring it into your histogram, you can use the normalize again here. And now you see these are the X values here of the positions. These are the Y values to see if something is going upwards or it's higher in the scene. You see, you get more white here. And the same for Z. And if you go here to positions, you see this here in this interesting colorful image. And this is a typical image which you normally see for a world position path. And this information stores, like I've said, in every pixel exactly the coordinate of the hit point of the ray. And this is now something the volume fog is using. So if we drag this in and we go back here now to the color, you now see that this here is a real coordinate. It's not Z, it's really the coordinate of the point. We generate on this coordinate of a point a sphere or cube, and we can move it around. The cool thing now is that you really see, if I go here over an object, you have to ignore everything which is outside here of the alpha at the moment. You will see that now this system really knows exactly which points are inside of this sphere and which points are not, because depending on the coordinate. And now you can change the size here, and you also can soften the edge. And this is, for example, useful if you say we place here, for example, this guy somewhere here. Okay. And then we take the original one. Let's get rid of that. Let's take a color corrector here after the renderer and place it here. Make a really funny color correction, or let's reset it. Let's go here and we bring down the gain for a night scene. So now everything is night. And then we take the output of the volume fog, which is at the moment, if we look here, a whole image, but we don't want to have the whole image. So let's go here through the whole thing. Here we have the colors. I don't want to have any colors and things like that. I only want to have the fog. And then we use that in the color corrector in the blue here as a mask. And if we now take a look here, you see everything which is inside of the sphere is now in the dark. But what we want is, we want to have everything dark, but this area. So to do that, we have to invert the mask here. And you can really easily do that if you go here to the settings of the color corrector and say here that you want to apply the masks not in the right way, but in the inverted way. And now we have here this light source, which we can now place around here with this thingy here, and we can change. We also have here size, and you see it's really correct from the depth inside of the scene. So this is a use of the world position path where you really have the data where every pixel was inside of the whole scene, and the two fog ideas which we have. Okay, let's talk a last topic about depth. There's another thing which we can do with the depth, and this is placing things on each other. And this is a really interesting thing. So let's take here a background node and we make it red, and we go to the settings and say this is 200 by 200, and we place that now. Oops, auto resolution is on. This is something we don't want. Okay, 200 by 200, and we place it over with the help of the merge over our image. Now we have here this plane here. At the moment it's placed over the image completely. But what I want is I want to place it depending on the depth of the pixel value. So we still talk about Z here. And what we can do inside of the merge node is we can go here to the channels and activate here a depth merge. If you activate that now here, you can now sample again. And now you see that we are now sampling here points. And what I do now here with the sample, you maybe have seen the Z value here, -12, is that now the merge node compares every pixel of the foreground with the Z value of the background. And we say we want to place it only if we are behind here this 12. And we can change that, -13 for example. And you see it goes to the back. And this is a really powerful technique because, yeah, this is a 2D image. The only information we have is the Z depth of every pixel. And you remember that in the introduction I talked with you about that we are in a set-based workflow, which is not anti-aliased, and it's depending on the resolution. And you see it here in these little artifacts. We can render here the foreground better, but you will see that the Z information is really depending here on the resolution of our blade. So this is the downside of it, but it's a really powerful technique. And in other applications, it's named Z-Merge, for example, and it's built into the standard merge node here, really easily to find. Okay, now we are leaving the Z world, and beside the Z, we also had the normals and we had the world position. But we also have information about the scene if something is moving, for example. For this, I added here this moving shape. And what I want is I want to bring a post effect for MotionBlur into that. To do that, there are different approaches, but one approach here is then that we say we want to have a vector pass. If you go here to the renderer, you see we have two vectors, a forward vector and a backward vector. We can have them both here. It depends on the tool which vector is used. If you go now here, you see these are the vectors. Let's go here to the normal vectors, or better to say the vectors, not the back vectors. You now see that on every pixel here, we store now in X and Y in which direction the pixel moves. And you see this is the information which we deliver now. And this information is now stored in this pixel or behind this pixel, behind this D pixel. And we now can use, for example, a vector motion blur. Here it is, vector motion blur. And if we hook that now up into the viewer, you now see that we can use now these channels here, X and Y. It's vector X and Y. And you get now a motion blur for that. Big advantage is it's fast to render because it's a post effect. And you have here a wonderful scaler which you can use. A little side note of that, vector motion blur works with X and Y. Sometimes if you come from a 3D application, you have to shuffle the channels around or to flip them. And that's the reason why you have here two ticks. But we will talk about this topic in a later tutorial. I think this is enough about motion vectors. You can also generate them with the Oflow tools, which are part of the studio versions of Resolve and Fusion Studio, which is not part of the free version, but these Oflow tools generate then from moving images these vectors, and you can use then these tools, which need motion vectors also for retiming and things like that, frame repair, stretching, and so on. One thing which is now quite important is a special kind of data path, which we have now here in our output channels list, which is ObjectID and MaterialID. You don't see Cryptomat here. So Cryptomat is something which you can use inside of Fusion with the help of the Cryptomat tool, which you install with the reactor. But this renderer here, the Fusion renderer is not able to generate CryptoMat from itself. It uses the older system, which is named ObjectID and MaterialID, and we can generate them directly here. So if you go now here and tick these two, and go back into your list, you will see that we have now the ObjectIDs here and the MaterialIDs, and you don't see anything here. Why? It's only a number which is stored, and this is something we can't see here. But you will see the result in a moment. So let's check how this works. And this is quite good integrated inside of Fusion, I think. So let's test this first with a color corrector. Normally, if you have a color corrector, let's make everything blue. It works on everything, but you have a mask. You can generate a mask directly through your mask tools here inside of Fusion, or you can use the CryptoMat and generate a mask and pipe it in here. But you also, if you have object or MaterialIDs, can use them directly here. What you have to do inside of Fusion is, many nodes here have this option. You select the node and go here to the settings. And inside of the settings, you see here, use object and material. You have to activate now what you want. I want to use the ObjectIDs. So I tick this here, and suddenly this thing is not doing anything, but you get now here this list. Now you have to find out which ObjectID an object has. How to find this out? The easiest way is with the sample. You go here to the sample, and I sample here, for example, now this Suzanne here, and you see the ObjectID is number 4 and the MaterialID is number 14. So that's the way how you can address now here objects. And now this color corrector is always working on this Suzanne here. This is also a data path which you have behind every pixel, so you also can generate them in your 3D application. I will show you later in another tutorial how to do this in Blender, how you get object and MaterialIDs, and how you use your CryptoMat. I hope this helps you also here. Now we have seen a lot. We haven't finished this list here because now we need a little bit more stuff here. So let's get rid of that here. We now add the shader node here. And the shader node really is a beast. What the shader node needs to really work is we need a normals path. So normals is active, great. We also need, I think, UVs, so texture coordinates. These are the UVs, we need them. And we also need normals. That's it, normals and UVs. And this node here is used for ReLighting purposes. You can see if you now look into the result, it looks really, really ugly. It's happy, but it looks ugly. The reason for this is that we now add a light here onto our objects, and our objects, you remember, this is a rendering. So this is a 2D image. Let's remember that this is only this 2D image here. Is simulated that it has a material appearance. This material appearance is something you can change here. So you see here you have a diffuse contribution. If you remove that, nothing here at the moment. So let's first remove the reflection and the specular. I think you now can see it. So this is the ambient contribution. You see you can relight now your image with the ambient here. We also can change the diffuse contribution, and we also can have a specular. And this was the really ugly thing which we had before, this specular thing here. We also have here a shader which we can change, so you can now tell how specular and diffuse works, and we also can change the colors if you have metals, for example, or you want to bring them down here in a nicer way. So this is something you can do here. But there's another really interesting thing which you can do here. And for this, we have this additional port here, which is a reflection map. For this, we imported an HDRI. So let's place an HDRI here. And let's look into that, how it looks. Okay, it's quite dark because it's a linear image. What we can do now here is we can profile the image, or we can gamut it here directly. Let's first test how it looks. See what it does. Okay, Now we take this HDRI and pipe it into this shader, and now I bring the reflection up. Now you see we get suddenly on the surfaces the reflection of this HDRI here. So let's take a gamut node and try to bring it up here so that's a little bit brighter. You see we can use that with the gamut node, and if you activate and deactivate that, you see it changes here the appearance, because now we have also reflections here on the floor and things like that. But now you see how the whole thing works. So this shader node is good for relighting and for reflections. If you want now to have only one object relit, for example only the sphere, you remember we can go to the shader node, go to the settings, say we want to use only the objects and sample, for example, only this sphere here. And now you see why the combination here is interesting. Now we have a mask only for the sphere. And now we can go back here, say, okay, we want to have a little bit more reflection here on the sphere. We want to have a little bit of a specular, but the specular sits at the wrong place. I want to have it here. And for this, we have here the equator and the polar height. So we can now move the polar height around, and also here the equator. And you see, it's not perfect, but it really helps if you use it subtle to change here the appearance of an object which is rendered and you don't want to re-render anymore or something like that. This is the shader node, quite powerful here. That's enough for this node. The last node which I have here in the list is the texture node. Let's throw this out and take here from the effects. Now the texture node. Okay. What the texture node helps you is to retexture objects which are rendered. And for this, again, we need data, and for this I think we only need the UVs, which we have activated here with the texture coordinates. Okay. We need a texture to retexture the whole thing. So let's go to the media pool, go into my textures, take this texture map here and pipe it in here. And the moment you do that, you see that now your whole scene is retextured with this wonderful image here. If you don't see that, if you see chaos, you don't have UVs on your object. UVs are surface coordinates which a 3D application normally delivers if you generated UVs, which you need in every 3D application for texturing. And these objects here have UVs, and if you then generate these texture coordinates here inside of the render node, or you pipe them through, you can see them here, they look like this here, then this texture node is able to use them for retexturing purposes. And like always, we can now go here, say I want to have it only here on the sphere, and I think I want to swap them here. We also can rotate these around. You can try a little bit to find the right direction here so that you are happy then. You also can scale them here, and that's it. Move them around. I think that's a whole bunch of interesting things here which you can do with the help of these deep pixel nodes. And I think the tutorial is quite long again, so let's close this tutorial at this point, and in the next lesson we talk then about how to now generate these in an external application and how to bring them into the Fusion world so that the directions and all this stuff are fitting. I hope this helped you. If you have any questions, please write in the comments below. If you like these kind of tutorials, please subscribe, give me a thumbs up. If you want to support my work, please consider becoming a Patreon of me. I really appreciate that. And you also find the files on my Patreon. So see you next time, your Helge Maus. Have fun.